All right, so last week we learned how to evaluate logs. This week we'll be learning how to solve logarithms. Now, on the previous slide you saw that we have 4 steps when we're trying to solve a logarithm. We are being asked to isolate the log, then perform the opposite operation, then solve for the variable, then check the solution. These are your normal steps when you're solving for a variable. Now, when we're looking at this first problem, we have log base 2 of x is equal to 3. Our first step is to isolate the logarithm. Now, the logarithm is the word log with its base, which in this case is 2, and then the argument x. All of this together combines to be the entire logarithm. So when I say isolate the logarithm, I mean isolate this log base 2 of x. So in this case, it is already isolated and I can move on to step 2. Step 2 tells me to perform the opposite operation. So right now what's happening is I'm taking the log base 2 of x. So my operation here is logarithm. Opposite operation is exponential, meaning I have to exponentiate both sides. I have to do that big base thing that we learned last week. So we keep the base the same. In this problem, the base is 2. So I create a big base of 2 on both sides. So now log base 2 of x is all in the exponent. I just exponentiated it. So on the left-hand side here, 2 raised to the log base 2 of x power, that 2 and log base 2 cancel each other out. And all I'm left with is that x. Then on the right-hand side, I have 2 raised to the power of 3. So this means 2 times 2 times 2. You're multiplying 2 times itself 3 times. 2 times 2 is 4, times another 2 is 8. So now we just have to check our solution. I'm going to plug our solution of 8 back in for the original x. So I have log base 2 of 8 is equal to 3. So from last week we learned that when we have a log of a number, what we're asking is, what power do you raise the base to equal the argument? So what power do you raise 2 to be 8? You raise 2 to the power of 3 to equal 8. So this left-hand side is 3. Log base 2 of 8 is 3. And that does equal our right-hand side, which was also a 3. So this checks out. This original solution is valid. It is our answer. X equals 8. So let's move on and try this next example, number 2. We this time have log base 3 of 2x minus 1 plus 2 equals 4. Now before we get started on this problem, I do want to make a little side note here. This example has log base 3 of 2x minus 1 equals 4. Notice the difference between this example and this example. Our true example has parentheses, meaning everything I've written in blue here is what is being logged. That is our argument. Over here, there are not parentheses. So only the 2x is the argument. That is the only thing being logged. So when I'm being asked to isolate the log, you're isolating log base 3 of 2x. the -1 is not part of the log. It is not part of the argument. So you would have to move that -1 away from our log first. Just wanted to make that quick little side note so that you understood other examples a little bit better. All right, back to number 2. Step 1 tells us to isolate the logarithm. So here I have log base 3 with the argument of 2x minus 1. Meaning I do have an extra number there, that plus 2, that is not part of the log. So my first step is to move that positive 2 away. I do the opposite operation and I subtract 2. Whatever I do to both one side, I do to both. So these cancel. 4 minus 2 gives us a positive 2 now. So I have log base 3 of 2x minus 1 is equal to 2. Now my logarithm has been isolated. I can move on to step 2, which is perform the opposite operation. So my end goal is to solve for x. I'm trying to get x all by itself. In order to do that, it is currently the argument of a log. I need to get rid of that log. Opposite operation tells me I have to exponentiate both sides. The opposite operation of log is exponential. So I have to exponentiate both sides. Our base is 3, so I create a big base of 3 on both sides. Now, log base 3 of 2x minus 1 is in the exponent. 3 raised to the log base 3 power cancels. And you're left with 2x minus 1 equals, on the right-hand side, 3 raised to the power of 2. Now, our third step is solve for the variable, right? Our end goal was trying to get x all by itself, solve for x. So, 3 raised to the power of 2, 3 squared is 9. And I have 2x minus 1. Trying to get x by itself, this is now just a linear problem, a linear equation here. So, first thing I do, I add 1 to get it away from the x. 9 plus 1 is 10. Then I have a 2 attached to the x. So I need to divide both sides by 2, because right now it's 2 times x. Opposite operation of multiplication is divide. So you divide by 2 to get the 2 off of the x. 10 divided by 2 is 5. Now before we can circle our solution, we must check our solution. Meaning I plug 5 in, I substitute 5 in for our original variable x. So I have log base 3 of 2 times 5 minus 1 plus 2 is equal to 4. All right. So first thing I'm going to do is simplify my argument. 2 times 5 is 10, minus 1 is 9. So I have log base 3 of 9 plus 2 is equal to 4. Now notice I've gotten rid of my parentheses here. I've done this because I now only have one term as my argument. So there are no need for parentheses. Could you have put them there? Yes. But there's no need. You now see it's just log base 3 of 9, and then after the log is the plus 2. So now, just like last week, we are going to evaluate this log. Log base 3 of 9 asks the question, what power do you raise 3 to equal 9? Well, you raise 3 to the power of 2 to equal 9. So this evaluates to be 2. Then I'm just going to bring down the rest. So, well, this evaluates to be 2. I'm going to bring down the rest, plus 2. Bring down the 4. 2 plus 2 is 4. Both sides of the equation equal. So this solution checks out. Our solution of x equals 5 is valid. And I can circle it.